Okay, hello students. I'm just wanting to run through some of the sample working from the titration track for volumetric analysis from the last couple of lessons. So today we're just going to try and express the molarity of the unknown, which is the ethanoic acid in the vinegar. So what we'll do is we'll just run through our calculations. So first of all, just set up with what you do know. So we were working with sodium hydroxide, and I think we need to go C, N, and V. And you had 0.1 molar sodium hydroxide. And you need to get the mean of 3 concordant titers. So let's just assume, for example, that the mean of those concordant titers, mean of 3 concordant titers, so that's what's dropping out of the burette, and let's just assume it's something like 14.1 milliliters. So what we need to do is calculate the number of moles in those 3 concordant titers. So we just need to consider the formula C equals N on V, so the concentration equals the number of moles divided by the volume. But we know the concentration, we know the volume, so therefore we need to find the number of moles. So N equals CV. So what we're going to do is just going to go 0.1 moles per litre multiplied by, now we need to convert that into litres. Okay, and you can see we're just going to have to move the decimal place one place. So in those 14.1 mils, we have got 0.0041 moles. Now we want to look at the vinegar, or the concentration of the ethanoic acid in the vinegar. Now, first of all, we diluted it, didn't we? So we'll think about dilution. So in the class, I think we had 25 ml pipettes and 250 ml volumetric flasks. So your dilution, or your dilution factor, was what? 250 ml volumetric flasks over a 25 ml pipette. So that's a dilution factor of 10. So we'll keep that in mind for later. Now let's set up our equation, C, N, and V. So we're just wanting to identify what we know. Now we selected, you may have been 20 mils or 25 mils, so I'm just going to assume that you had 20 mils in the conical flask at the bottom of the titration. So we'll put that in litres. You may have used 25 to be consistent, so you just need to change that as you need to. Do we know the concentration? Not yet. Do we know the number of moles? Well, we can work that out because we know the balanced equation, so we know how they react. So it's NaOH is reacting with the ethanoic acid. And what we're producing CH3COONA, so sodium acetate, and just producing water as well. So one of these reacts with one of these to produce one of these and one of these. So the logic follows, if we have that many moles of sodium hydroxide, we're going to get the same amount of moles for ethanoic acid. So let's put that in. So that's 0.00141 moles. Next step is that we're going to have to work out the concentration. Now remember, our formula is C equals N on V. So C equals the number of moles over the volume, 0.00141 moles I'm running out of space here, maybe I'll just zoom it up a bit, over 0.02 litres. Now that will give us an answer in moles per litre. So let's do that. Oops, lost it. So 0.00141 divided by 0.02, and that will give us a concentration of 0.705 moles per litre of ethanoic acid. Now remember, we had to dilute it at the start, so now this is where we account for the dilution. So for dilution, and so we're just going to get the concentration of the ethanoic acid in the vinegar is just going to be, what did we say, 0.0705 moles per litre multiplied by that dilution factor of 10. And so that should give us 0.705. Whoops. I just have to move the decimal place one. So 705 moles per litre. So this means for every litre we've got 0.705 moles of ethanoic acid. Now you'll also be asked to express it in a couple of different ways. So we can express it, for example, in grams per kilogram, or we can express it as, sometimes you'll be asked for ppm, or sometimes you'll be asked to express it as percent mass over volume or volume over volume. But your textbook or your experiment today wants you to express it in mass over volume. So when we express it in mass over volume, we just need to remember that percent mass over volume is the same as saying the mass of CH3COOH over the volume of solution. In this case, we need to use another formula, and this is the number of moles equals the mass over the molar mass. Now we know the number of moles for every litre. So we know that N equals this here, 0.705 moles for every litre of water. Now 1 litre of water equals 1000 grams. And we'll leave it at that for the moment. And then what else do we need to consider? We need to consider the molar mass. I'm going to, I'll stop that and we'll do it this way. So we know the molar mass, sorry, I've led you down the garden path there. So the molar mass from the periodic table is what? Carbon plus 3 hydrogen plus another carbon plus 2 oxygen plus another hydrogen, and that's around 60 grams per mole. So what we do now to calculate the mass is multiply the number of moles by the molar mass. So let's keep our working under each other. So the mass in grams equals the number of moles, 0.705 moles, in 1 litre of water. We're multiplying it by 60 grams per mole. So the answer is going to be in grams. And that should be, well, 6 sevens are 42, so it's going to be around 42 grams. So it's going to be 42.336, and that's going to be grams. So now we know the mass of the ethanoic acid in 1 litre of solution. So it's going to be 42.336 grams for every 1,000 grams of water. So we can just move that decimal place 3 times, and that's going to go 0.42336 grams. No, just percent. Oh yeah, that's no, just a fraction because we've cancelled the units. But we're going to express it as a percentage, so it's just going to be 4.23 and 4% mass over volume.